Door close. Hello. Okay. So now today we are starting our next unit, work, power, energy. The unit name is work, power, and energy. Already you are familiar with these terminologies. What is work, what is power, and what is energy. So in the work, we are dealing with the numericals of work done. Then we will also solve the numericals based on power, how to calculate the power, what is the formula. And then energy. In energy, we are having potential energy and kinetic energy. Then law of conservation of energy and work energy principle. So these bits are covered in this unit. So first of all, we will see what is work. So work. So write it down. Now work is defined. Work is defined as product of force and displacement. Product of force and displacement. If a displacement of the body, if the displacement of the body is in the direction of the force, then work done is said to be positive. And if displacement of a body is in the opposite direction, of the force, then the work done is said to be negative. Okay, so basically work is nothing but the product of force and displacement. So summation F into S is nothing but your work done, where S is the displacement, F is the force. So if a displacement of a body is in the direction of the force, then the work done is said to be positive. And if the displacement of the body is in the opposite direction to that of force, then work done is said to be negative. Now we will draw the diagram for this. Suppose now this is the surface. Now on this surface, this body is here. Okay. Now on this body, if we apply a force, now if I apply the force F, if the force F is applied, so due to this force F, there is a displacement of the body. Suppose the body is moved up to this distance. Okay, now this is the current position of the body, and the displacement of the body is S. So this displacement of the body, this is S. S is the displacement of the body. Okay. Then in this case, you can see the force is in towards this direction, towards rightward direction. The force is in the rightward direction. Displacement is also in the same direction. Okay. So in this case, now if I want to calculate the work done, then the work done will be W is the notation for work done. W is equal to, it is F into S, and this is positive because the force and the displacement are in the same direction. Now for the negative work done, again this is the surface. On the surface, this body is there. Now this body is in motion, and suppose this body is moving forward. Suppose a car is there and it is moving. Now suddenly brakes are applied. Okay. Now when you apply the brakes, okay, suppose the motion is to the motion is of this box is towards the right hand side. Motion of this vehicle is towards the right hand side. And suppose when you apply the brakes, the opposite force will be in this direction. The braking force will be in this direction. Okay, opposite direction to the motion. So this is the force. But even though if you apply the brakes, the vehicle doesn't stop at this point. Okay, it will travel some distance and then it will stop. Suppose the distance travel is S. Okay. Suppose here that vehicle stops, and again the displacement is same. The displacement of this block is S. The displacement of this block is S. So now in this case, what is the work done? So the work done W is equal to, it is definitely F into S. Okay, because this force is there in the direction of displacement, but it is in the opposite direction. So this is minus. So in this case, your work done will be minus. Why minus? Because the displaced direction of the displacement and the direction of the force are opposite to each other. Okay. The displacement is not in the direction of the force. Here you can see the displacement is in the direction of the force. So it is positive. Here displacement is not in the direction of the force. Force is in opposite direction. So your work done is negative. Okay. So this is about work. And this is the example of what we can say when the vehicle is there and it is in motion at any instant t. And now suppose the driver suddenly applies the brakes, then the force will be in this direction, but still the vehicle travels some distance and then it will stop. Suddenly जागेवरती कुठलाच vehicle थांबत नाही. Okay. So this is the perfect example of negative work done. This is the example of positive work done. Is it clear? Work done, work. Okay. So now after this work done, we will see next is in the case of inclined load, in the case of inclined force, consider the component of the force, the component in the direction component in the direction of the displacement while while evaluating while evaluating work done. Okay. So in the case of inclined force, you should consider the component of the force which is in the direction of the displacement to calculate the work done. Now suppose again, this is the surface, this is the body, suppose. And this is the surface. Okay. Now suppose on this body force is applied, but it is in this direction now. This is the direction of the force. This is F. Okay. And this is your horizontal line. And this angle is suppose now theta. Okay. And due to this force, what is happened? This body is moved further. And the displacement, suppose S is the displacement of the body, and now the current position of the body is here. And this is the displacement which I will show here. This is the displacement of the body due to the applied force. This is the displacement. Now we want to calculate the work done. What is the work done in this case? Okay. So you know that work done is equal to F into S. So now here we have to resolve this force first. Now if you resolve this force, you will get one component in this direction and the another component is in this direction. Okay. So your this angle is theta, so this will become F cos theta, and this is your F sin theta. Now forget about this main force, consider the components, and in these two components, see the component which is in the direction of the displacement. Okay, so it may be in the same sense or it may be in the opposite sense. But if the displacement is horizontal, you should consider horizontal force. If the displacement is vertical, if you should consider vertical force. Okay, so now here our displacement is horizontal. So this is the horizontal component F cos theta. So it will be F cos theta into S. Why we have taken F cos theta? Because our displacement is horizontal. So we have to take horizontal component. Now whether it is positive or negative, now see the direction. Now see the direction of F cos theta is towards right side. Displacement is also towards right side. So this is plus. So this is plus. So your work done is F cos theta into S in this case, whenever the inclined force is applied. Okay. So next is the unit. So the unit of work. Now what is the unit of work from this formula? It is Newton meter, because displacement is in the meter, force we can calculate it in the Newton. So it is Newton meter, or Newton meter is called as joule. Newton meter it is called as joule. So 1 joule is nothing but it is 1 Newton meter, and 1 kilojoule is equal to 1 kilonewton meter. Okay, 1 kilojoule is 1 kilonewton meter. So this is all about the work. Now the next is power. What is power? So the power is defined as rate of doing work. Rate of doing work. So rate means you have to divide it by time. Okay. So rate of doing work. So if I write the formula for power, so first of all we will write the unit. The unit of power is, it is the rate of doing work. So work done divided by time. So it is Newton meter per second or joule per second, or joule per second means it is called as watt. 1 watt is equal to 1 joule per second, which is equal to 1 Newton meter per second. Okay, 1 watt is equal to 1 joule per second, which is equal to 1 Newton meter per second. Okay. So this is required. When the power is given in watt, you have to convert it into Newton meter per second for the calculations. So here power is equal to P is equal to power is equal to work done, rate of doing work, so work done upon time. Okay. So P is equal to work done. Work done, how do we calculate? It is F into S divided by T. Okay. But S means what? Displacement. T means what? Time. So displacement upon time is nothing but velocity. So it is F into V. Okay. So in general, power P is equal to summation F into V. Similar it is for the work done also. For work done, if I write the equation in general equation, then work done is equal to, it is summation F into S. Okay, work done is equal to what? It is summation F into S. Similarly, here power is equal to summation F into V. Power is equal to summation F into V. Is it understood? What is work done? What is power? Okay, so we will take some 2-3 numericals on the power and work done. And after that, we will move to the energy, and then we will take the numericals from the energy. So energy also, it is very easy. You know, potential energy formula is 1/2 mv square for potential energy. Kinetic energy. Kinetic energy half mv square, and for potential energy mgh. That's it. Based on this unit is very easy. Based on the formulas, we need to solve the numericals. Okay. So we will take the problem now. Calculate the work done. Calculate the work done in pulling a block of 200 kg for 10 meter on a smooth inclined plane, at an angle of 15 degree with the horizontal. So very simple numerical is there. See, calculate the work done. So we want to calculate the work done. We need to calculate that. For a block, its mass is given. Displacement is also given 10 meter on a smooth inclined plane. Smooth plane. The wording here, it is smooth plane. Smooth planes means what is the value of mu? Mu must be 0. So frictional force is 0. Whenever you come across the word smooth, you should take the value of mu is 0. And if you take the value of mu is 0, you know that F is equal to mu into R. This is the formula for frictional force. So ultimately your frictional force will become 0 when your mu is 0. So here the plane is inclined at an angle of 15 degree to the horizontal. So we will draw the diagram of this. So here this is the inclined plane, which is inclined at an angle of 15 degree. So this angle, it is given as 15 degree. Here what they have told us, pulling a block a block is there. This is the block. This is the block. So the weight of the block will act through the CG of this block. This is the centroid of the block. Okay. This is the centroid of the block. या ब्लॉकला तुम्हाला वर ओढायचंय, घेऊन जायचंय. किती किती डिस्प्लेसमेंट व्हायला पाहिजे याची? 10 meter. Okay. So the displacement of the block will be 10 meter. This is 10 meter. Now here mass is given m. M is equal to 200 kg. So what is weight now? We need here weight. We always consider here weight. So W is equal to what? Mass into acceleration due to gravity, mg. Mass is equal to W by g करत होता ना तुम्ही. So W is equal to mg. M is 200 into g is 9.81. What is the value? (1962). So it is 1962 Newton. So weight I will show now here. The weight is, it will act vertically downwards. This is the weight. Weight is 1962. 1962 Newton. Okay. There is no frictional force because it is a smooth surface. Now we will resolve this. See, now this inclined plane is our x-axis. This inclined plane is our x-axis, and perpendicular to this is our y-axis. So here, this is our y-axis. नेहमी आपण इन्क्लाइन प्लेनचे प्रॉब्लेम असंच सॉल्व्ह करतो, लक्षात घ्या. जो काही इन्क्लाइन प्लेन आहे त्याला आपण एक्स ऍक्सिस म्हणतो आणि त्याला परपेंडिक्युलर असलेला प्लेन आपला काय असतो? वाय ऍक्सिस. ऑलवेज वी सॉल्व्ह द प्रॉब्लेम ऑफ इन्क्लाइन प्लेन लाईक दिस इन एनी युनिट. ओके, you can see. So now if we resolve this, if I resolve this, now this is the plane. So one component will be in this direction of this load, and the another component will be perpendicular to the plane. It is like this. So if this angle is 15, this angle is also 15. Angle between the lines is angle between their normals. So this will become 1962 cos of 15 degree. This is 1962 sin of 15 degree. And then we will draw the normal reaction also. So here this is the normal reaction R. This is the normal reaction R. Okay. So what is the work done now? So work done W is equal to, it is summation F into S. This is the work done. Okay. So work done W is equal to summation F means what? See, work done is in this plane. Work done कुठल्या plane मध्ये बघा. Work done is in this inclined plane, which is our x-axis. So in the force section, you should consider the force which are in this direction only. Okay, which are parallel to this plane. Those forces should be considered. So here the displacement is on this x-axis, which is inclined at an 15 degree. So this force will contribute to this displacement. So here it is 1962 sin of 15 into the displacement is 10. But here one more thing you can see, displacement is in the right hand side direction, and the force is in leftward direction. So this displacement is minus. Okay, this displacement is minus. So if you solve this, you will get the value of W. What is the value?
5078.02.
5078.02 minus. It is Newton meter per second. Okay, or here you can say that W, which is equal to, is it, huh? Sorry, work done, it is Newton meter, correct. So it is in Newton meter. Okay. So this also you can write it as minus 5078.02 joules. Okay. And you can also write this W is equal to, it is minus 5.078 kilojoule. Okay. So this is the very simple numerical. This is for understanding the concept. इथं बघा लक्ष द्यायसारखी गोष्ट ही आहे की या समेशन एफ मध्ये आपण हा फोर्स घेतलेला नाहीये 1962 cos 15 किंवा नॉर्मल रिएक्शन पण घेतलेली नाहीये. का घेतलेली नाहीये? तर डिस्प्लेसमेंट तुमची ज्या डायरेक्शनला व्हायला लागलेली आहे त्याच डायरेक्शनला असलेले फोर्सेस इथं समेशन एफ मध्ये घ्यायचे. बाकीच्या डायरेक्शनचे फोर्सेस इथं येणार नाहीत. ओके. इन्स्टेड ऑफ दिस डिस्प्लेसमेंट विच इज हॉरिझॉन्टल, इफ द डिस्प्लेसमेंट इज गिवन व्हर्टिकल, जर व्हर्टिकल डिस्प्लेसमेंट दिली असती तर हे दोन फोर्सेस तुम्हाला घ्यावे लागले असते. ओके. ज्या डायरेक्शनला डिस्प्लेसमेंट आहे त्याच डायरेक्शनचे फोर्सेस इथं समेशन एफ मध्ये घ्यायचे कॅल्क्युलेशन करताना. सो द नेक्स्ट न्यूमेरिकल नाउ. The locomotive and train together has mass of 200 ton. And tractive resistance of 100 Newton per ton. If the train can move up a grade of 1 in 125. Just a moment. So it is move up the grade 1 in 125 with a constant speed, of 28.8 kilometer per hour. Find the power of locomotive. Find the power of locomotive. Okay. Locomotive means engine. power of locomotive. Okay, this is the first part. Then the problem is also continued. Also, problem is continued. Find also find now this is the second part. Also find the speed. Also find the speed with with which which the train can attain. With which म्हणू नका. Find the speed which म्हणा फक्त with काढून टाका. Which train can attain on level track with same tractive resistance and power of locomotive So here what we need to calculate, find the power of locomotive. First this mass is given, tractive resistance is given, then the slope is given 1 in 125, constant speed is given, velocity is also given to us. Find the power of locomotive, this is the first part. Then also find the speed of the train, it is the second part. Also find the speed which train can attain on level track with same tractive resistance. Okay, with same tractive resistance. So this is the problem. So पहिल्यांदा काय सांगितलं त्यांनी, ट्रेनचे तुम्हाला डिटेल्स दिले. ट्रॅक्टिव्ह रेजिस्टन्स मीन्स फ्रिक्शनल फोर्स. Write it down somewhere. Tractive resistance means it is the frictional force. Okay. If the train can move in a grade, slope दिलेला आहे with a constant speed, find the power of locomotive. हा फर्स्ट पार्ट झाला. आणि परत ही ट्रेन जी आहे ती इन्क्लाइन प्लेन वर न जाता जर लेवल प्लेन वरती असली असती, लेवल प्लेन वरती असली असती त्याच कंडिशनला, तर त्याची वेलोसिटी काय असली असती, असा क्वेश्चन तुम्हाला विचारलेला. So here I will write first what is the mass of the train. M is equal to, it is 200 ton, which is equal to how many kgs? 200 into 10 raised to 3 kg. Okay, so this is the mass. Now from mass we can calculate weight. W is equal to m into g. So it is m is 200 into 10 raised to 3 kg into 9.81. What is the answer? It is 1962 into 10 raised to 3 Newton. So this is the weight of the train. Okay. Then velocity v, it is given as 28.8 kilometer per hour. So 28.8 kilometer per hour is equal to 28.8 into 5 by 18. If you multiply it by 5 by 18, you will get the answer in meter per second directly. किलोमीटरचं मीटर करा, आवरचं सेकंड करा, त्याच्यापेक्षा हा फॅक्टर लक्षात ठेवा. 5 by 18. When you need to convert from kilometer per hour to meter per second, you just multiply that term by 5 by 18. So you will directly get the value in meter per second. So what is the answer? 8. So the answer is 8 meter per second. This is the velocity. Okay, 8 meter per second is the velocity, and the frictional force, tractive force F, it is given as 100 Newton per ton. 100 Newton per ton means what? For 1 ton, it is 100 Newton. For 1 ton, it is 100 Newton. Now, what is the weight? Mass, it is 200 ton. So for 200 ton, for 200 ton, it is how much? Okay. समजतंय का? 100 न्यूटन पर टन दिलेलं आहे. 100 न्यूटन पर टन म्हणजे एका टनला किती फोर्स आहे? फ्रिक्शनचा फोर्स 100 न्यूटन एका टन साठी. मग आपलं वेट किती आहे? 200 टन आहे. मग 200 टनाला किती असणार आहे? It is, so therefore your frictional force, it is 200 into 10 raised to 3 आलं का? Okay, 200 into 10 raised to 3. हाँ. Okay, so 20 into 10 raised to 3.
Yes, sir.
So it is 20 into 10 raised to 3. So this is the frictional force. Okay, now we will draw the diagram. What the problem says. We want to calculate the power. Now here, this is the inclined plane. Now this is the horizontal line. So here it is the angle slope, but slope is directly not given to us. Slope साठी त्यांनी काय सांगितलंय? 1 in 125. So if you go 1 unit vertical, you have to go 125 unit horizontal. That is the meaning of 1 in 125. Unit means anything, but it should be same for both the sides. If you come 1 meter vertical, you should go 125 meter horizontal. If you come 1 centimeter vertical, then you have to go 125 centimeter horizontal. Okay, म्हणजे हे 1 in 125 म्हणजे कसं असतंय तर हे असं जर तुम्ही 1 आलात, ओके, हे किती असू दे, 1 mm असू दे, 1 सेंटीमीटर असू दे किंवा 1 मीटर किंवा किलोमीटर असू दे. ओके, तर इथं हॉरिझॉन्टल किती जायला पाहिजे तुम्ही? 125 इन द सेम युनिट. In the same unit you should go. If you come down by 1 mm, then this should be 125 mm. If this is 1 centimeter, this should be 125 centimeter. And if you join these 2 points now if you join these 2 points like this, if you join these 2 points, then this line will be your sloping line. Okay, this line is your slope. Okay, and you can find out this angle. Okay, so same thing we will apply over here now. So it is 1 in 125. So what I will do, I will show here, this is 1 and here this horizontal is 125. Okay, this is 1 in 125, this is 1 and this is 125. Now we can easily find out this angle theta, and whatever this angle is there, same is the angle will be there, because these two are the parallel lines and this will act as a transverse. So these two becomes corresponding angle. If this is theta, this angle is also theta, because these two are the corresponding angles. Now we want to calculate this theta. How do we calculate that? हे 90 डिग्री है ना, opposite side माहिती है, adjacent side माहिती, यूज करा की tan of theta. Tan theta is equal to opposite side upon adjacent side. So theta is equal to tan inverse of 1 upon 125. 0.45. So theta is 0.45 degree. So your this angle is 0.45 degree. Okay, 0.45 degree. Now we will draw the block. Here we will draw the locomotive. So I will draw the train now. This is the locomotive total. Here somewhere the centroid is there. Now the weight will act vertically downwards. So this is the weight. And what is this? How much it is? Weight म्हणजे W असते बरं का, इथं कधीही मास घ्यायचं नाही. मास इज डिफरंट, वेट इज डिफरंट. ओके, तुम्ही जे वजन काट्यावरती उभारून मोजता नेहमी, ते तुम्ही मास काउंट करता, तुमचं वेट काउंट करत नाही. आपण म्हणतो की नाही माझं वजन किती 100 किलो. ते खरं ऍक्च्युअली 100 किलो म्हणलं की ते मास झालं. इट इज मास, इट इज नॉट द वेट. ते आपण बोली भाषेमध्ये तसं म्हणतो की माझं वजन. वेट जर तुम्हाला काढायचं असेल तर ते 100 ला इंटू परत 9.81 करायचं. दॅट विल बी युअर ऍक्च्युअल वेट. काय जे असेल ते तुमचं 40 किलो, 60 किलो, 80, 100. आर यू गेटिंग द पॉइंट? Here we consider weight. So mass is this 200 into 10 raised to 3 kg. So when you multiply it by 9.81, then you get the weight. And this weight you should take here. 1962 into 10 raised to 3 Newton. This is the weight. Okay. This is the weight. Now where is the direction of the motion? Now we will see show the direction of the motion. Here you can see what they have given us in the numerical. If the train can move up, if the train can move up म्हणलेलं आहे म्हणजे ट्रेन कुठं चालली आहे वरच्या डायरेक्शनला. So the direction I will show. So this is the direction of the motion. In this direction the train is moving. Okay, so this is the direction of the motion. It is moving up. Now you can show the other forces also. So here if I resolve this weight, this is acting vertically downward. So one component will be in this direction, perpendicular to this surface, and the another will be in this direction, parallel to this surface. So if this angle is 0.45, this angle also it is 0.45. Okay, it is 0.45. So this will become cos or sine?
Sine. Cos.
Okay, 1962 into 10 raised to 3 cos of 0.45, and this is 1962 into 10 raised to 3 sine of 0.45. Okay. Now we will show the normal reaction also. This is the normal reaction. This is the normal reaction R. This is the normal reaction R. And here the frictional force is there. Normally, why we require the normal reaction? Generally, आपल्याला normal reaction कशाला लागते? ज्या वेळेला तुम्हाला म्यू ची व्हॅल्यू दिलेली आहे, कोएफिशियंट ऑफ फ्रिक्शन दिलेला आहे आणि फ्रिक्शनल फोर्सची व्हॅल्यू तुम्हाला डायरेक्ट दिलेली नाही, इथं कसं तुम्हाला डायरेक्ट व्हॅल्यू कॅल्क्युलेट करता आली फ्रिक्शनल फोर्सची. पण ज्या प्रॉब्लेम मध्ये तुम्हाला फ्रिक्शनल फोर्स डायरेक्टली दिलेला नसतो, जिथं तुम्हाला म्यू ची व्हॅल्यू दिलेली असते, तिथं तुम्ही काय करता, पहिल्यांदा या आर ची व्हॅल्यू कॅल्क्युलेट करता and then frictional force is equal to mu into r, and then you will get this value. Okay, but in this numerical we don't require r, as we are having directly this value, frictional force value. So I will show here the frictional force. So this is the direction, this is the direction of motion. So frictional force will be in the opposite direction of the motion. So this is the direction of the frictional force. This is your F, frictional force. Okay, this is the F, frictional force. And if this is the direction of the motion, then the direction of the velocity is also same. Velocity पण कुठल्या डायरेक्शनला असणार आहे, याच डायरेक्शनला असणार. Okay, this is the direction of the velocity. Same thing is there. Whatever you do for the work done, same sign conventions we have to use for the power. For work done, formula is summation F into S. For power is formula is summation F into V. So the forces which are in the direction of the velocity, those we consider plus, which are in the opposite direction to velocity, that will be minus. Okay. So here now we will apply, we will calculate the power. So I will write the formula. P is equal to summation F into V. Now pay attention over here. P is equal to summation F into V. Now how to take the forces? First of all, see where is the velocity. See, the engine is moving in this direction. Okay, velocity's direction is in this plane, which is parallel to this inclined plane. Okay, so you must take the forces which are in this plane only. These forces will not come into the picture as your velocity is in this direction. Okay, so या direction ला कुठले कुठले forces आहेत? It is 1962 into 10 raised to 3 sine of 0.45. This is one force, and second parallel to this plane is this frictional force F. Okay, so these two forces you should consider while doing the calculation. Now see, velocity is in this direction towards the right hand side, and this force is towards the left hand side, and frictional force is also towards the left hand side. So these two forces we should take it as a negative minus. So here I can write P is equal to, here in the bracket, minus 1962 into 10 raised to 3 into cos of 0.45. Okay, this is the first force. Again minus
सर तिथं साइन ऑफ आहे.
sine है क्या? Correct. Okay. So here sine of 0.45 minus 20 into 10 raised to 3, and you multiply this by velocity. Okay. So what is the velocity? Velocity is v. So into v is the velocity. Velocity is 8. We have calculated now 8 meter per second here on the inclined plane. So if you solve this, you will get the value of power. It will be minus तर आन्सर आलेलं आहे 285.46 into 10 raised to 3 watt म्हणजे जूल पर सेकंड, न्यूटन मीटर पर सेकंड. Please check the calculation once again. किती आलं? ब्रॅकेट टाकला का व्यवस्थित? 11.25.
minus 28 point
हाँ minus 28.32
into 10 raised to 4.
Okay, minus 28.32 into 10 raised to 4. It is Newton meter per second, or you can call this as a joule per second, or you can call it as a watt. These are the units. So if you see, I can write this as minus. Here if I shift this decimal point over there, then it will be 283.2 into 10 raised to 3 joule, which is nothing but minus 283.2 kilojoule. Okay, kilojoule. Others, please do check who have got that answer 1 point something or 11 point something. They have made the common mistake. Check this calculation once again. This is the correct answer, because this answer is there here also in the notes. Have you got this answer now? Why? You do separate calculation. Minus 1962 into 10 raised to 3. Then answer must be there. दो कॅल्क्युलेट करा आपण कोणाच तरी. इथलं चुकलंय का तुमचं चुकलंय? So it is minus 1962. Sine of minus 1962 1000 into sine of 45 minus this one into 8. हाँ आलं का? काय केलं? आधीचं? हाँ आलं का? Okay, so now this is the answer. So this is the first part. Okay, this is the first part here. Power, find the power of locomotive. So first part is over. Now what they have said us, Also find the speed of the train which can attend on level track. So now instead of this inclined plane, if the train is moving on the level plane, on the horizontal plane with same frictional force, with the same tractive resistance, then what will be the velocity of the train? That we need to find out. Find the speed. Okay. So now we will take this train on the level track. So this is the level track, means it is perfectly horizontal. This is our locomotive. Here somewhere the centroid is there. Now what is the weight? Weight, it is acting vertically downwards. So this is the weight. And here the normal reaction is there. R, and then weight is 1962 into 10 raised to 3 Newton. Okay. And the tractive resistance, frictional force F. Here the frictional force F is, what is the value of the frictional force? It is 20 into 10 raised to 3 Newton. Okay. Now motion, direction of motion. This is the direction of motion. And this is the direction of velocity. ज्या direction ला motion आहे त्याच direction ला velocity direction असणार. So this is velocity, direction of the velocity in the direction of motion. इकडे चाललेलं frictional force इकडे दाखवलेला आपण. Okay. So now again we know that power is equal to what? Summation F into V. So what is the power? Same tractive resistance madlele. So the power will be same. So what is the power? Power is 283.2 into 10 raised to 3. This is the power which we have calculated, Newton meter per second. Okay. In summation F, now the motion velocity is in horizontal direction. So in this direction, which force is there? Only the frictional force is there. In this plane, in the horizontal plane, which force is there? Only the frictional force is there. And this frictional force is in the opposite direction to the velocity. So it will be minus 20 into 10 raised to 3. Okay. This is summation F. Into velocity V as it is. We need to calculate the speed for the same tractive resistance. Okay. So therefore, V is equal to, what is the velocity? What is the answer? Minus 14.16 meter per second. But here you can write velocity is never negative. Therefore, your final answer should be V is equal to 14.16 meter per second. A minus sign कशामुळे आलेला आहे? Direction मुळे आलेला. The value is not negative. The sign negative is due to the direction. Okay. So this is the answer, velocity. So we have calculated both power and velocity. We have calculated both power and velocity. Okay. This is the answer for velocity. And this is the answer for power. Okay. So these two are the answers which have been asked in the numerical. हे विचारलेलं आपल्याला प्रॉब्लेम मध्ये. Is it clear? समजलंय का काय केलंय ते?
Yes, sir.
Okay. So in this way we can calculate the work done and power. So we will take one more problem where we need to consider the inertia force. That type of problem, one problem we will take. So here, next numerical is an engine of mass 50 ton pulls a train of pulls a train of 300 ton to an inclination of to an inclination of to an inclination of to an inclination of 1 in 100. The inclination is 1 in 100. Full stop. A train starts from rest and moves with a uniform speed and moves with a uniform speed of 36 kilometer per hour of 36 kilometer per hour. Full stop. Find the power transmitted by the engine. Find the power transmitted by the engine if the tractive resistance if the tractive resistance is 60 Newton per ton. Also find power transmitted by the engine if the acceleration of engine is 0.2 meter per second square. So read the problem carefully and see, are you able to solve it or not? Try to solve it. So what is given now? Here. See, an engine of mass 50 ton pulls a train of 300 ton. The mass किती घ्यायचं मग? Totally 350 because engine is pulling the train. Train means मागचे जे bogies आहेत बट इंजिन इज हॅव्हिंग ऑल्सो सेल्फ वेट, म्हणजे स्वतःचा पण वेट आहे ना, त्याला ते पण ओढून पुढे घेऊन जावं लागणार. ओके, सो द टोटल मास इज 350 टन. सो m is equal to mass, it is 350 ton, which is equal to 350 into 10 raised to 3 kg. Okay, so weight, now what is weight? Weight is 350 into 10 raised to 3 into 9.81. What is the answer for the weight? It is 3433, right? 3433.5 into 10 raised to 3 kg Newton. 10 raised to 3 Newton. It is converted into Newton. Then velocity v, it is 36 kilometer per hour, which is equal to 36 into 5 by 18, which is equal to 10 meter per second. Okay. And power we need to calculate. What is power? They have asked us. So here we will draw the diagram. This is inclined plane. Here the train is there. Here somewhere the centroid. Okay. A train starts from rest, moves with a uniform speed. Okay. And the inclination of 1 in 100 mandlele. What is the inclination this time? It is 1 in 100. So this inclination, this is 1. And here this horizontal part is 100. This part is 1. This horizontal part is 100. Find out this angle. So use tan inverse of 1 by 100. You will directly get the angle. Find out this angle theta. Whatever this angle is there, same angle will be here also. 0.57. 0.57. Please check the calculation.
It is correct, sir.
Okay. So 0.57. Now I will show the weight. The weight of this total weight is acting vertically downwards. So this total weight is 3433.5 into 10 raised to 3 Newton. Now we need to resolve this. So if you resolve, one component will be parallel to this plane and another component will be perpendicular to this plane. So here, if this angle is 0.57 degree, this angle is also 0.57 degree. So it is 3433.5 into 10 raised to 3. It is cos of 0.57. This is 3433.5 into 10 raised to 3 sine of 0.57. Okay. Sine of 0.57 degree. Now we will show the normal reaction. So this is the normal reaction R. This is the normal reaction R, and the frictional force. So the frictional force is F. So here I will show the frictional force. This is the frictional force. This frictional force is F. Okay, F is the frictional force. What is the frictional force? Tractive resistance is given 60 Newton per ton. एका टन साठी किती आहे 60 न्यूटन. मग आपलं वेट किती आहे टोटल 350 टन. सो कॅल्क्युलेट द फ्रिक्शनल फोर्स. So the frictional force is equal to, it will be 60 into 350, correct? What is the answer? 21 into 10 raised to 3 Newton. Okay, it is 21 into 10 raised to 3 Newton. So in the first part, find the power transmitted by the engine if the tractive resistance is 60 Newton per ton. So here the first part is there. And the second part of the problem is also find the power transmitted by the engine if the acceleration is this and this. Okay, 0.2. So first we will solve the first part. So in the first part, now we will use the equation power P is equal to summation F into V. So what we are going to write in the summation F? So in the summation F, you can see what is the direction of the motion. So this is the direction of the motion here on this side. This is the direction of the motion. So your velocity is in this direction. Whichever is the direction of the motion, same is the direction of the velocity. So your force in this plane, now this is the direction. So in this direction, this force is there, but this force is in the opposite direction to that of the direction of the velocity. The direction of the velocity is also like this. This is the direction of the velocity V. Okay. So this force is opposite in this direction to the direction of the velocity. So here it is P is equal to 3433.5 into 10 to the power 3 sine of 0.57 degree, but this is minus. Then again frictional force is also along this plane and it is moving in the opposite direction to that of velocity. So again minus 21 into 10 raised to 3, 21 into 10 raised to 3. This bracket is complete. This is for summation F into V. Velocity is 10. So therefore power is equal to, what is the answer? The answer with me is 551.57 into 10 raised to 3 watt. Joule per second is watt or Newton meter per second. Please check the calculation and let me know whether the answer is right or wrong.
It is right, sir.
Answer is right?
Yes,
okay. Okay. Now the second part of the problem. Now in the second part, what they have asked, if when acceleration A is equal to 0.2 meter per second square, acceleration of the engine. Okay, this is the acceleration of the engine. Then what will be the power? Then what will be the power? Okay. So now see, here now everything will remain same. Just the additional thing is that the acceleration. Okay. The engine is having the acceleration now. Now it is not a uniform acceleration. It is having the acceleration of 0.2 meter per second square. So due to acceleration, additional force will be getting induced in the train. And due to acceleration, the additional force which is getting included is MA. F is equal to MA. A formula है ना तुमच्याकडे, F is equal to MA. So A, due to the acceleration, the force will also get induced over here. So what is the acceleration? Acceleration is 0.28. So this force MA is the inertia force. This also we have seen in the previous chapter. So this force is also here because of this acceleration, and it is in the opposite direction to the direction of the motion. So here the force will present in addition to this, and this force will be MA. Okay. So in the above equation, you have to add this force. You have to consider this force also. So M is the mass. Mass is the 350 into 10 raised to 3. Mass is already known to us directly. A is the acceleration 0.2. So here we can write the equation. P is equal to, it is minus 3433.5 into 10 raised to 3 sine of 0.57 degree minus 21 into 10 raised to 3 as it is, again minus this force field, because velocity is in this direction and inertia force is in the opposite direction. So minus MA, what is the value of M? 350 into 10 raised to 3 multiplied by A is 0.2. So this term will get added. This term is our MA term. This term is nothing but it is MA. Because of acceleration, this term will come into the picture. So MA, which is equal to, here the answer which I am having, it is 1251.57 into 10 raised to 3 watt. Huh? 10 raised to 3 multiply करायचं राहिलं. velocity ने multiply करायचं राहिलं, correct. So here velocity, this is F into V. V is the velocity which is 10. So therefore P is equal to, it is 1251.57 into 10 raised to 3 watt. 10 raised to 3 watt. So this is the answer. Is it over? Shall we take the next problem? Okay. So the next problem is an engine of mass. नाही घेतलेला घ्या डिस्प्लेसमेंट डिलेशन. An engine of mass 50 ton together with locomotive moving on inclined track, moving on inclined track of 1% grade, of 1% grade with constant speed of 28.8 kilometer per hour. Stop. Find the power of locomotive, power of locomotive, Okay, full stop. Also find the distance, on a level track, the train can travel. With same tractive resistance with same tractive resistance and power and power. So, frictional frictional force is 10 Newton per ton, 10 Newton per ton, and time interval is 5 minutes, and time interval is 5 minutes. Okay. So let us write the given data. What is given? First mass m is equal to, what is the mass? 50 ton, which is equal to 50 into 10 to the power 3 kg. Okay. Then from mass calculate weight. W is equal to 50 into 10 to the power 3 is the mass into 9.81. So you will get the weight. So it is nearly about 490.5 into 10 raised to 3 Newton. Okay, please check the calculations. Velocity 28.8 kilometer per hour, which is equal to 28.8 into 5 by 18, which is equal to 8 meter per second. Then the frictional force F is equal to, it is 10 Newton per ton. So it is 10 into 50 ton. Okay. So it will be 500. 500 is not 500 Newton. Barabar hai? So now we will draw the inclined plane first. Here what they have said, the engine of mass 50 Newton together with a locomotive moving on inclined track of 1% grade. So slope of the track is 1% with a constant speed. Find the power of locomotive. इथं तुमचा फर्स्ट पार्ट संपला आणि इथनं पुढे सेकंड पार्ट चालू होते प्रॉब्लेमचा. ओके, फक्त तुम्हाला फ्रिक्शनल फोर्स हा घ्यायचा आहे जिथं जे कॉमन आहे तो. ओके, so in the first part what we will do now, we will draw the diagram. And the 1% is given grade. 1% म्हणजे किती असतंय? 1 by 100. 1% means it is divided by 100. So vertical 1, horizontal is 100. So calculate this angle theta, which must be equal to this angle. What is the angle? 0.57. So 0.57 degree is the angle. So here somewhere the centroid is there. Now we will show the weight. Weight is acting vertically downward. The value of weight is 490.5 into 10 raised to 3 Newton. Okay. So now if we resolve it, then these are the components. So this will be 490.5 into 10 raised to 3. What it is? Cos of 0.57 degree, because this angle is also same. And here it is 490.5 into 10 raised to 3 sine of 0.57. direction of motion. This is the direction of motion. Okay, direction of velocity, direction of motion. Then the frictional force. Frictional force is in the opposite direction to direction of the motion. So the frictional force will be like this, opposite direction. What is the value of frictional force? It is 500 Newton. 500 Newton is the frictional force. Now calculate the power. So it is very easy. P is equal to power is equal to summation F into V. So power P is equal to, for summation F, this is, see velocity. आता या प्लेन मध्ये असलेले फोर्सेस घ्यायचे. या प्लेन मध्ये कोण कोण आहे या प्लेनला पॅरलल, तर हा एक फोर्स आहे आणि हा एक फोर्स आहे, आणि दोघं अपोजिट डायरेक्शनला चाललेले आहेत, म्हणजे वेलोसिटीच्या अपोजिट डायरेक्शनला. सो दोघं कसे असणार? निगेटिव्ह. सो इट इज मायनस 490.5 into 10 raised to 3 sine of 0.57, again minus, it is 500 equal to, so into करायचं राहिलं ना. This is only summation F. This is only summation F. Now multiplied by velocity. Velocity V is 8. Answer 43.03 into 10 raised to 3 watt Newton meter per second. We check the answer. Okay. This is the answer. So now next part is also find the distance on level track. So distance level track म्हणजे आता हीच जर ट्रेन जर level track वरती घेतली. Okay, now the same train is there on the level track, and what distance it will travel, that displacement we want to calculate now. They have asked us the find the distance on the level track of the train can travel with same tractive resistance and power. म्हणजे ही जी पॉवर दिलेली आहे ही पॉवर आणि हा फ्रिक्शनल फोर्स हे सेम आहेत. ओके, तर लेवल ग्राउंड असेल तर ट्रेन किती लांब जाईल, किती त्याची डिस्प्लेसमेंट होईल असं आपल्याला विचारलंय. विथ द सेम पॉवर अँड सेम ट्रॅक्टिव्ह रेजिस्टन्स. इथे लिहिलंय बघा, ट्रॅक्टिव्ह रेजिस्टन्स, सेम ट्रॅक्टिव्ह रेजिस्टन्स अँड पॉवर म्हणलेले. ओके, सो वी विल सॉल्व इट नाउ. Here again I will draw the level track. This is the level track. Train, centroid, weight, normal reaction, direction of velocity, then frictional force which is in opposite direction. Okay, so the frictional force is 500 Newton and this weight is 490.5 into 10 raised to 3 Newton. Here is our normal reaction. Okay, so on the level ground it will cross the distance. What distance it will cross? So P is equal to power is equal to summation F into V. So now this is in this direction, the velocity is there. So this is the direction where you should consider the forces. So parallel to this direction 500 is there. So but they have told us the power will be same. So what is the value of power? 43.03 into 10 raised to 3. 43.03 into 10 raised to 3. Their power is same. Summation F, it is only 500. It is minus, say, into velocity. What is the value of velocity? 8 का 10 है. So here velocity we can write it as S upon T, distance upon time. Velocity is nothing but distance upon time, because we want to calculate the value of this S. This will be 43.03 into 10 raised to 3, which is equal to minus 500 into distance is S divided by time is 5. Therefore, S is equal to displacement. Calculate the value. हा कशात घ्यायला पाहिजे तुम्हीच सांगायचं ते सेकंड मध्ये करेक्ट. सो हियर इट इज 300 ना 5 मिनिट दिलेत ना. ओके करेक्ट. कारण आपण युनिट वापरतो न्यूटन मीटर पर सेकंद, त्याच्यामुळे टाइम सेकंद मध्ये घ्या. टाइम 5 minutes. 5 minutes is equal to 300 seconds. Hmm? 25818. So it is 25.818 into 10 raised to 3 meter. बरोबर ना. So if you can keep this answer as it is also okay, or you can write which is equal to 25.81 kilometer. Okay, this is nothing but 25.81 kilometer. So if you put the answer here as it is, then it is also okay. तुमचा आन्सर आला तुम्हाला युनिट कन्वर्जन येत नसलं तर आहे तसं ठेवा, जास्त कन्वर्ट करायला जाऊ नका. बट फायनल आन्सर चांगलं जमत असलं तर असं लिहा, हे जरा इफेक्टिव्ह वाटतंय असं. ओके. So these are the problems which we have covered now, all the variety. Okay, we have seen only when the work done, how to calculate work done. Then we have seen when the velocity is given, how to calculate power. Then we have seen when the acceleration is given, then also how to calculate the power. And in this numerical, we have seen when the displacement is, how to calculate the displacement based on power. Or reverse way also it can happen. They may give you the value of displacement and they will ask you to calculate this power. ओके, पण दोघांपैकी एक तर तुम्हाला द्यावं लागणार. इथं काय केलंय त्यांनी, पॉवरची व्हॅल्यू तीच घ्या म्हणले आणि डिस्प्लेसमेंट काढा म्हणले. एखाद्या प्रॉब्लेम मध्ये तुम्हाला असं सांगतील की ही जी डिस्प्लेसमेंट आहे, द डिस्प्लेसमेंट इज 25 किलोमीटर्स. मग इथं तुम्ही डिस्प्लेसमेंटची व्हॅल्यू ठेवायची आणि पॉवर कॅल्क्युलेट करायची, असा पण प्रॉब्लेम असू शकतो. ओके, व्हॉट एव्हर प्रॉब्लेम वी हॅव टेकन अप टिल राईट नाउ, राईट फ्रॉम द फर्स्ट युनिट, द प्रॉब्लेम कॅन बी आस्क्ड बाय कीपिंग सम नोईंग व्हॅल्यू अननोन अँड अननोन व्हॅल्यू नोन. उलट करू शकतात, समजलं. So in this way we have to solve these problems. Okay, so all the types of problems regarding work done and power we have covered now. Now we will move to the further next, that is the energy, next bit. Okay, we will move to the energy. Energy. What is energy? How do you define energy? Capacity to do work. Correct. Okay. So energy, it is defined as, capacity to do the work. Okay. Capacity to do the work. So the relation is work done work done is equal to the energy stored in the body. Work done is equal to the body. Full stop. Therefore, the unit of work, the unit of work and energy, unit of work and energy are same. Okay. So the energy is measured in joules or kilojoules. Okay, joules or kilojoules. There are main there are two main types असं म्हणा. There are two main types of energy which are given below. First is potential energy. Potential energy. What is the potential energy? झालेलं आहे तुम्हाला कायनेटिक एनर्जी, पोटेन्शियल एनर्जी. So here you can write the definition. Correct. By virtue of its position. Okay. So write the definition. The energy possessed by the body on the virtue of its position is called as potential energy. It's called as potential energy. The potential energy, P is the short form we use. Potential energy formula is